Welcome back to This Week in Business. I'm Brian Burnell. You've probably seen the images, a life-saving heart or organ for transplant being delivered in an ice cooler, literally an ice cooler. Well, now there's an alternative, a much more advanced option. And it's made by a Cambridge company, Paragonix Technologies. CEO Bill Edelman is joining us with the story, and it's called the SherpaPak Cardiac Transport System. Welcome to This Week in Business. Appreciate you coming in.
My pleasure.
Okay, we're going to take a look at some video of this unit. Tell me what it is and how it's different from the way we have traditionally moved organs for transplant.
It'd be a pleasure. So the device that the video will show you demonstrates that the product itself, the Paragonix SherpaPak, the cardiac transport device, holds an organ, holds the heart in this case, in the center of a sterile chamber and envelops it with a preservation fluid which has been used for many years, and where we maintain the thermal properties of that preservation fluid in a very narrow temperature range. And that helps to promote the viability of the tissue of the heart as it's being transported from a donor to a recipient.
So in the past, when you're essentially packing it in ice, are you doing damage to the organ?
Well, in several ways you can be. The temperature of ice is 0, and the tissue of the heart is almost in direct contact with the ice. It's being sandwiched between heavy layers of ice. And when that happens, it deforms the organ and can also freeze the organ. So you can end up with frostbite and frozen regions of the heart. And the reaction is that upon implantation and resuscitation, that heart may not perform in an appropriate way. We can avoid that by thermal management and by the way we isolate the heart inside the chamber of our device.
It strikes me that if, as you talk about that and how much better the heart will perform, any organ will perform using the SherpaPak, why didn't someone think of this sooner? Because ice is a pretty basic concept of, okay, we'll throw ice in a bucket, we'll put it in there, and we'll get it out the door.
So there are several examples in medical device technology where the non-obvious solution ends up being obvious. And the objective is, how can we improve the quality of the donated organ? It's such a precious resource.
Yeah.
And the need is overwhelming. There's probably 50,000 people in this country in end-stage heart failure. Only 3,500 implants occur, and maybe 8,000 organs are available for donation. So if we can in any way improve the utilization of the organs that are available and improve the quality of the organs that are implanted, the outcome for the recipients and their families is profound.
Well, and it's interesting because you and I were talking earlier, and you said, you know, think about an organ donation and transplant. Everything is carefully controlled until now, except transport.
That's true. It's amazing when you think about it. If you think of medical technology managing a patient in surgery, it's incredible, the level of detail, the level of quality management. For a donor, the same thing is true. When a patient transitions into a donation, that donor is managed in an amazing way. The transplant teams take a great deal of care in terms of how they approach and deal with the explantation of organs.
Sure.
But then they're packed in ice, and then they're transported in a way that completely ignores the quality that was attending prior to that. On the receiving end, the implantation is associated with tremendous oversight, but the organ that's in transit, it's in a completely black box environment. Nobody knows what happens other than when it arrives, it could be damaged. And so we try to illuminate that by putting controls around that moment of donation and that transport period with our technology.
I picture transplant surgeons looking at this and saying, finally. Is that the kind of reaction you're getting?
We're getting overwhelming reaction wherever we are. The product is approved by FDA in the United States, and it has CE clearance in Europe. And we have a direct sales force selling this now all throughout the United States. The reaction's been phenomenal. We've gotten complete conversion of accounts where all of their donations, implantations are using the Sherpa device. And in Europe, we're getting the same reaction.
And it also provides, you can transport them further than you've ever been able to before, right?
Well, the results have been demonstrating to us that transport times can actually increase. We have several centers reporting that they're able to fly greater distances to recover organs that previously were out of reach, which makes the availability of donation and donor organs more appropriate for matching for their recipient patients.
I feel like in looking at this technology and hearing you talk about it, it's something that should have been thought of before, which makes me think there must have been challenges. What were the challenges in creating this?
The challenges were to create a completely disposable device that basically extended the current standard of care without imposing new technology that required retraining at the clinical level. In order to drive adoption of a device like this, the surgical team must be provided a technology which they can relate to rapidly and can convert to. And that's what this product was and has done. And our investment in this design has been in part to allow rapid adoption and using this product throughout the donation process.
How rapidly can these surgeons use this? I mean, what's the training for the surgeons?
So we have clinical education specialists spread throughout the United States. They provide maybe an hour of hands-on training with some refreshers, and then literally these centers are able to stand on their own.
That is, it's remarkable. Like I say, it seems so intuitive. Let's talk a little bit about, as much as you can, about organ donation in general. Does this, I mean, I don't know if this will help encourage donations, but obviously it's a big issue in this country.
It's a tremendously overwhelming need, especially in areas such as lung and heart, where the donations absolutely are less than what the need is. So whether or not this product will induce donations to occur and increase them in absolute numbers, there's no way to know that. But the idea of donation is a very pervasive theme that awareness needs to be built around, because there really is no substitute in end-stage heart failure for a replacement heart. There are mechanical means, and there are amazing technologies. But over time, the clinical results have shown that a donated heart has the best chances of survival for a patient in end-stage heart failure.
Is there a difference between the, I don't know, durability maybe is the word, the damage that can be done to a heart as opposed to a liver, as opposed to a lung? Is this an adjustable product that can address any need for any organ?
So we currently have approval for heart and for kidney. Kidneys are much more robust, and they can last for longer periods of time. It's an amazing physiologic difference between hearts and kidneys. Lungs, on the other hand, what's interesting about lungs is that the way that they are explanted from a donor is that they're partially inflated, and then they're flown by jet. And when you fly a lung by jet, it can overinflate because cabin pressure is less than sea level. When that happens, the lung will stretch. When that occurs, it can be damaged. So our technology for Sherpa Lung, which is now in development, and we've announced it previously in the press, is designed to accommodate this transmembrane pressure and not allow it to occur. So the lung will never overinflate while it's being flown to its implantation site. People who hear about it in lung transplantation absolutely need this.
It sounds like you still have work to do, that there is more work and perhaps more products that you can create for this.
Our objective is to own the landscape completely from donation to implantation for every solid organ that's in transport. And so we currently have approved heart and kidney. We will develop shortly for lung, and we will follow that on with all the other solid organs that currently are in demand.
Amazing. Bill Edelman, Paragonix Technologies, thank you. Fascinating.
Pleasure. Thank you.